Determine the empirical and molecular formula of each of the following substances. Part B. Epinephrine, a hormone secreted into the bloodstream in times of danger or stress, contains 59% carbon, 7.1% hydrogen, 26.2% oxygen, and 7.7% nitrogen by mass. Its molecular weight is about 180 AMU. Okay, so this is another empirical formula problem. I'm going to have to start by pretending all these percents are actually mass. I'm going to pretend I have about 100 grams so that each of my percent values is actually my gram amount. Then I'm thinking I'm going to have to convert those things to moles because that's what you do in stoichiometry. Now I'm going to write down my 59 grams of carbon, 7.1 grams of hydrogen, 26.2 grams of oxygen, and 7.7 grams of nitrogen. Now we're going to convert these to moles by dividing by the molar mass. That's really convenient for us because molar mass has units of grams per mole. When you divide by those fractions, you flip things over. Wonderful units cancel, and then they will be in the units we want them to be in. So, okay, we have the molar mass of carbon. That was 12.01. Now hydrogen is 1.008. Oxygen is going to be our lovely 16.00. Don't forget to write all of your units. It's very important to write out everything. It helps you keep track of stuff. 14.01 for nitrogen. Here we go. Let's tap all these numbers into the calculator. 59 divided by 12.01 grams. That will get me about, let's see, I think it's 4.9-ish. Yes. I'm going to keep those two sig figs because of that 59. Then 7.1 divided by 1.008. That's just about 7.0. Okay, and those are moles of hydrogen. Now we'll do 26.2 divided by 16. That'll get me about 1.63, keeping the 3 sig figs because this number's weird. Then 7.7 divided by 14.01. Clearly that already looks like a half, but I'm going to do it anyway. 0.55. And that's moles of nitrogen. Now I'm going to look at these guys, and I'm looking for a ratio, because this is empirical formulas. I'm going to pick my smallest number, and I'm going to divide by the smallest number. Our smallest number here is the half, the 0.55. I'm going to divide all of my amounts. Let's see, this oxygen ratio looks to be about 3. Close enough. All right, 7.00 divided by 0.55. That's... in my calculator it says 12.7, but for empirical formula problems that's kind of close enough to 13. Then we will go to 4.9 moles of carbon divided by 0.55. That gets me about 8.9. Again, close enough to 9 for an empirical formula problem. Now if you see something like a third or 2/3, you're definitely going to want to multiply those out. But these ones are close enough. Okay, so we're going to have C9H13O3N as our empirical formula. Again, empirical formulas are just the basic whole number mole ratios of these atoms inside of a formula. Now let's check the molecular formula and see if the molar mass of this compound is going to match that molecular weight given at the beginning of the problem. We have 9 carbons, so that will be 9 times 12.01, the atomic mass unit amount on the periodic table. 13 times 1.008, 3 times 16, and 1 times 14.01. add up all of those multiplication things together, and we're going to get something around, my calculator looks like 183 for the molar mass of this compound. That's about 180, so I say this is our molecular formula. Check. This is close enough. Ladies and gentlemen, this formula, C9H13O3N, is both our empirical formula and our molecular formula. And now this problem is done.